Hello everyone and welcome to this webinar on the new EMODnet vessel density maps. My name is Andréane Marsan and I work for the European Marine Observation and Data Network, or EMODnet Secretariat in short. And as you probably know, EMODnet's Human Activity team released earlier this week the long-awaited vessel density maps. And today we will have a webinar in two stages. So first of all, we will have a 15 to 20-minute presentation, and then we will have a short question and answer session of approximately 15 minutes. So for the first part, for the presentation, we will show how the vessel density map work, the data we have with nice examples. We will also show an overview of the method used and how to download and open the data. And the speakers will be Alessandro Petito, coordinator of EMODnet Human Activities, Luigi Falco, GIS coordinator, and William Adnams, GIS developer. So as I said, after the presentation, we will have a question and answer session. And I will give you now a few instructions on how we will interact together during this webinar. So your mic has been muted by default, and we advise you to stay in the muted mode during the whole webinar because there's too many of you. So we cannot afford to let you all speak at the same time. And also it will result in a lot of background noise. So please stay muted during all the webinar. But you can ask questions in another way. So we invite you to use the chat or the little question icon at the bottom of the dashboard to ask a question during the webinar. So you can ask a question at any time, but only we will answer your question at the end during the question and answer session. But not worry, so I will take note of your question during the webinar, and I will read your question at the end, and the human activity team will reply. So I think it's now time to start the webinar, and so I give now the floor to the EMODnet human activity team.
Hello everybody. This is Alessandro speaking, Alessandro Petito, the coordinator of EMODnet Human Activities. And I'm gonna just give you a quick overview of the freshly released vessel density map. I'm gonna share my screen. Okay, you should now see my screen with EMODnet Human Activities and the density map. But before we get started, I would like to get started actually from what you see here, because this is what we did was a unique method that, to our knowledge, hasn't been used so far by anybody else, and it came after a few brainstorming sessions. And it's very important to understand what we are representing, because there are a lot of density maps around from free sources, from commercial sources, but apart from being nice pictures to look at, you need to understand what they want to represent. So it's very important that we start from here. And you can see that what we represent here, our measure of density, is expressed as a number of hours per square kilometer per month, which means that you can select different months of the year, and you're gonna retrieve a value of density per square kilometer, which is the number of hours that ships spend in the cells of our grid. So why are we showing the number of hours per square kilometer per month? As you probably already know, there are several ways to represent vessel density. And when we started out with this daunting task, our first question was a bit trivial, but what do we mean by density? What is vessel density? And you may have noticed that there are several methods around. One of them is very straightforward and is density is calculated by reconstructing vessel routes from AIS messages. I'm taking it for granted that everybody knows what an AIS message is. In case you don't, please be patient, because next week we're publishing a report with the full method used for the density map, and you will find a lot of details. Even though it's the first time you're not familiar with these issues, it's going to be very user friendly. Anyway, I was saying a very common method to make density maps is to recreate ship routes from AIS messages, which are ultimately positions sent by transponders on board ships and recorded by a receiver. So positions are points. From points, each point is identified by a unique identifier, the so-called MMSI number, that makes it possible to assign that message, that position, to a ship. So you can recreate ship routes. And what is the method that is very popular is the one represented in this figure. Okay, so suppose you have a grid made up of 4 cells. You have 2 ships, the black ship and the red ship, and you can, from the points, from the messages, you can recreate their routes, and then you simply, for each cell of your grid, you count the number of routes that cross the cell. So it's a very straightforward method, and what it gives you is basically the value of density is obtained by summing the routes that cross each cell. So in this example, you can see the A cell, neither the black ship nor the red ship are sailing this cell, so your density value is 0. You have only the black ship in the B cell, and your density value is 1. And in the C cell and in the D cell, you have both ships crossing, so the density value is the same as 2. As I said, this method is very straightforward. Helcom is using it in the Baltic Sea. And it's a good method, but it doesn't give the results we expected. It's very important to underline the results we expected, because there are several ways to make a density map, and no method is in principle better than the others. It ultimately boils down to what you want to represent. So in our case, we weren't too happy with this method, because you can see it to the naked eye. You can see that in the D cell, the black ship, it crosses the D cell only for a moment probably, but the density value is the same both for the C cell and and the D cell, because this method simply counts the number of crossings. So no matter the length of your route or the time you spent in the cell, the results would be the same. So what came to mind immediately afterwards was to using the same method, so recreating ship routes, but also calculating their length, which kind of gave results more in line with our expectations. As you can see, the values now are completely different. In the former example, we had the C cell and the D cell with the same value of density. If we calculate route length, then we have different results, because the density value of the C cell is more than 2 times higher than the D cell. But this method didn't give the expected result either, because in the end we came up with a definition of density that should be intended as a quantity that measures the degree of concentration of countable objects. So in our case, countable objects are ships in a physical space, and the physical space is the ocean that we represent here through a grid. With each cell 1 square kilometer. So how to do that? We could do that if you look at this picture. it's still another method. You can simply count. You still have the black sheep and the red sheep, and you could, in theory, what we know from AIS is that there is a default transmit rate, which for certain chips is variable between 2 and 10 seconds. So which means that every 2 seconds you have a new position of a ship. You have still the black sheep and the red sheep, and assuming that the ship positions are taken at regular time samples, one method to calculate density could be to simply count the ship positions, the messages in any cell. And this method, you can see it's a bit more in line with what we wanted to show, because consider that we're working on monthly density files, and the challenge is that over a month, you need to take into account a dimension that the former methods couldn't take into account, which is ship speed, because ships are moving all the time. So, and this method takes ship speed into account. You can see it. Suppose that the positions are taken at regular time samples. What is immediately visible is that the black ship is sailing faster than the red ship. And of course, this has an effect on results if you average your density calculation in a month, because if the black ship is sailing faster, it means that the expected probability of finding the black ship in the same cell is much lower compared with red ship. Of course, if the red ship is sailing slower, it will spend more time in the cell. And so we needed to, ideally, we could simply have a measure of density by calculating ship positions in a cell. In practice, this is impossible. This turned out to be impossible because you don't have regular time samples. You have different ships with different transmit rates. But above all, sometimes ships stop sending messages altogether for a number of reasons. Sometimes they're simply out of satellite coverage. Some other times, some ships, in some cases, it's been documented that they turn off their transponders on purpose, only to turn them on minutes or hours after, in some cases days after. So you miss a lot of positions in the meantime. Some other times there are just errors. A receiver misses a message. So this method is not reliable for the very simple reason that you don't have regular time samples. But this was the right way to go. We understood that, and so we just trying to figure out a workaround. And what we did is something halfway between the two methods I showed you. So we started from the ship positions. Okay. Now consider these 4 positions here: 0, 1, 2, and 3. So what we did is we created a line, but instead of creating a line for an entire ship route, we created a line every 2 consecutive positions of a ship. Okay, so now consider that each position, each AIS message comes with a timestamp. So when we create a line every 2 consecutive positions of a ship, we know the initial timestamp and the final timestamp, so we immediately know the duration, okay, of the route, the time that the ship took to move from point 0 from point 1. At the same time, because every message has coordinates, we also know the distance between these 2 points. And we did this every 2 consecutive positions of each ship. So what happens when a ship crosses a cell of our grid is the following. You see that we knew that the ship took 180 seconds for moving from point 0 to point 1. Okay, And what happens when the ship intersect the cell? We could calculate the distance, okay, sailed in this cell. And this was true for all the other segments in our route. So we were able to, in the end, to calculate the time spent by each ship individually in a given cell. By simply, you can read here. We know that the black ship, sorry, the first segment here of our route was from point 0 to point 1, 180 seconds, for a total length of 500 meters, of which 225 meters in the cell. So, sorry. Okay, so what we did was simply dividing the length of the segment in the cell by the total length of the segment, and multiply this by the total time of the segment, and that gave us the time spent in a cell. You could do this every 2 consecutive positions of a ship. You sum the results, and it returns the time spent by this ship in a cell. Now imagine doing this for all the ships that cross this cell in a month, and that gives us our value of density. Well, the value that it returns is the time spent by all ships in that cell for a month. But this value is very important because it is immediately convertible into a proper measure of density. Why I'm saying this? Because if suppose that all the ships that cross this cell in a month spend the equivalent of 30 days, okay, in time, 720 hours, 30 days. Now, suppose this is the month of April. The month of April has 30 days. If you divide the time spent by ships in that cell, which amounts to 30 days, by the total time in a month, in the case of the month of April, 30 days, again, you have 30 divided by 30, which gives you 1. It means that on average, the probability, you have a 30 probability of finding a ship in that cell, which amounts to 1 ship in the cell over a month. Of course, you could get the same results if 2 ships cross the cell for 15 days each. Any combination that averages to 1 will produce the same results, because what we're showing here is the average instantaneous number of ships in a month in a cell. So this quantity, the time value is immediately convertible to a proper measure of density. To be noted that, as I showed you, in EMODnet Human Activities, on EMODnet Human Activities portal, we're not showing the average number of instantaneous ship in a cell, but we're still showing the time spent in a cell by each ship. And this was because we thought that since this value is immediately convertible into a proper measure of density, we wanted to leave users free to normalize the value according to their preferred normalization method. You could do it with a month, or in theory, you could normalize by the number of time steps. Suppose you want to sample ships every 30 seconds. If you divide the time spent by 30 seconds, that will immediately give you the expected number of messages received in the cell over a month. So we prefer to leave it like that, just with the value of time, and it's it's okay because the calculation is quite easy. Everybody can download the original raster file from our portal and do the same and normalize the data so as to obtain a proper measure of density. In the future, if users so ask, we can of course always change this value and offer report a proper measure of density. It won't make any difference in practice because the relative values between the cells, of course, will inevitably remain the same. So now back to the portal. So what you see here is this nice picture is basically the number of hours per square kilometer per month of the year. Let's take an example. Let's take the month of August. Okay, I'm selected here all ship types, and what you're seeing are the time spent by all vessels in each of our cells. And you have this color ramp here from this light blue, a very low number of hours spent in that cell, until to dark red, which indicates a lot of time spent in the cell, more than 100 hours, from more than 100 hours upwards. And this is given by square kilometer of a cell. Afterwards, Luigi will give you more details on the grid that we used. So if we zoom in, we can see these squares, and these squares are the 1 square kilometer cells of our grid. You could get a density value from, a density value, the hours spent in each of these red square per month. You could change the month of the year, of course, and you might have different results. You could also select this average. Average here is basically the average monthly value. So basically, we average all the monthly values of density throughout the year, and this gives you the average value. What you can do, of course, is also change the ship type. Now I'm showing all ships type. All ship types, but of course you can select, one may decide to view only cargo ships, okay? Or maybe you may be interested in fishing vessels, and then you get, and you can see the patterns are completely different as one may expect. And why do we have these ship categories? These ship categories come from the AIS messages themselves. Actually, more ship types are available from AIS messages, but most of them were not particularly interesting for analysis. So we group them into homogeneous and coherent categories. The thing that we regret the most is that it's impossible to have a detail on cargo. I mean, cargo here is a very broad category that includes container ships, includes ro-ro ships, and unfortunately, it's not possible to break it down because the information from the AIS messages only refers to cargo as a whole. So we tried to break down this category by buying additional data from other providers, including the Lloyd's Register, but it was impossible to do so, either because some providers refused to sell us the data after they learned what we were going to do. Because don't forget that these EMODnet maps, the value added of these EMODnet maps is that they're entirely free. I mean, I'm not talking about the picture you're seeing on the website. I'm talking about the fact that you can download the data, the raster data, and carry out your own analysis. So a lot of providers didn't want to share with us the additional data, even though we were ready to purchase this data. Or just in one case, they were available to sell us data with more detailed ship types, but the price was completely out of our range, so we had to just turn down the proposal. And so these are the ship types that are available. It's in the future, it's possible that through negotiations we'll be able to buy more refined data sets and give you a more granular breakdown of ship types. That's what we hope, at least. And before I leave the floor to my colleagues to explain some more details about the method, what you can do with the map, how you can download the files or use the web services, I would like to show you some examples. For instance, one very interesting example is in the Adriatic Sea. Okay, if I select fishing vessels, okay, this is the average yearly value, okay? But it's very interesting to observe what happens in the Adriatic. If I, for instance, let's see the month of May, you can see the fishing patterns here, more or less. Then what happens, June is, okay, looks pretty much like May, and so does July, but you can see there's a difference here when you move to August. Okay, so July, look at this area here. We see July, they're fishing a lot in here, and August stop. This is a fishing ban in the Adriatic Sea, and you can see that as long as the fishing ban is in place, the fishing patterns, of course, change accordingly. So this breakdown by month of the year makes it possible to see what happens, the evolution of traffic. In this case, it's fishing vessels, but you could do it without the ship too. And I thought that this example is interesting because you can really appreciate the difference it makes when you set in place a fishing ban. So again, you can see July here, and you can see August, and the difference is quite stark. Another interesting, you can use this data to cross-check information you already have. So let's move to the Gulf of Burgas. Okay, the month of July, and I can set dredging or underwater operations as the ship type. And here's the Gulf of Burgas. You can see a lot of density here. Okay, you can see a lot of density here because this is the port, and of course ships spend a lot of time in port, and then they move and they stay here, and here again we have a cell with a relatively high value of density. What's going on here? Like I said, you could use this information, cross-check what you already knew, because if you look on the internet, and it's exactly in this time frame, so July 2017, there was the Port of Burgas closed the contract with a dredging company. So you can see, I mean, what was happening back then. You can see it clearly. And another very interesting example, and then I'll leave the floor to Luigi, is if you, in the North Sea, if we have a look at high-speed crafts, I'll put the average values. Okay. So you can see that high-speed crafts. So they, for instance, they depart from this port, and then they end up here, 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 here. What are they doing? What they're up to? Or you can see the same from Bruges, or from the UK, or from Amsterdam. Well, it turns out that if you activate the layer of wind farms, well, you find that out immediately. These are the speed crafts, the high-speed crafts that provide services to the crew that are working on offshore wind farms. It's clear from this picture. So, I mean, this is just examples of what you could do, but there's actually a lot more to it than meets the eye. People can just download the data and carry out their own analysis for a wide variety of purpose. I would now leave the floor to Luigi, who will tell you some more details about all the geographic processing, the GIS analysis, and the method and the software used. So, Luigi, the floor is yours.
Hi all, good morning. I am Luigi Falco, the GIS coordinator of EMODnet Human Activities. I'm going to quickly describe to you the method we developed to create the vessel density map. We want to allow people to calculate the average instantaneous number of vessels per unit area, giving them the number of hours. So, first of all, Alessandro, can I share my desktop?
Yes.
Yeah.
Okay, just a second.
Yeah. Okay. First of all, we have to define the area of interest. Then we created a grid, set up the machine. We have acquired and cleaned the AIS data, the raw AIS data. We have imported the AIS data into our relational database. We prepared the data for calculation. We import data into ArcGIS to create points and lines. Then we exported again data into a Postgres database to calculate density, enabling the PostGIS extension. And finally, we using GDAL utility command rasterize to create the final maps. So the first step was to define the area of interest. You know that EMODnet human activities is mandated to create vessel density map for all EU waters. So what we did is to define the area of interest, the red polygon in the image. You can see the red polygon in this image. Calculating a polygon as bounding box that envelope the spatial extent of all the EU sea basins. We took the EU sea basins geographical data set from the EEA, for the European Environmental Agency. So once we defined the bounding box, it means the area of interest. What we did is to intersect the area of interest with land. We did this because to remove land from the area of interest and have a lighter geographical file for next steps. So we intersect the red polygon with the polygons from European coastline. We obtain the final area of interest, the light blue in the image here, less land, without land. So the following step was to create a grid. We started using the EEA grids, national grids. You see the image here. The national grids don't cover the whole area of interest because they stop just around the national waters. So what we did is to merge all together the national grids and extend using the fishnet tool in ArcGIS this grid. You see in the image just 100 kilometer cells because the 1 kilometer cells is not possible to be visualized in a Word document in an image. So I'm using this as example. We extended the measured grid to the whole area of interest, and finally we cut from the area of interest the cells not useful for us. So we selected only cells that have their centroid in the area of interest or are within an inner buffer of 1,000 meters from the area of interest borders, the coastline, it means. We obtained a fully inspired compliant to 1 kilometer grid polygon for calculating density. The result was a grid with over 20 millions of cells stored as a feature class in a file geodatabase. You see here just an example of our grid in the Attic, around the Attic Peninsula. Then, once the grid was defined, we set up a machine to preparing the machine for the calculations. The machine chosen was an Intel Xeon with 3.3 gigahertz, 10 cores, with 32 gigabyte of memory, and we use an SSD as main disk, and we installed the following software in the machine. PostgreSQL 9.5 with PostGIS extension, ArcGIS Desktop Basic 10.6.1, and QGIS 3.4.5 Madeira with all the extension with as GDAL. We also virtualized a Linux distro because we use the Linux bash commands, shell commands, to clean the raw data. So the following step is to acquire and clean the IS data. Despite the data was already cleaned by our provider, CLS, we discovered, first of all, I want to show you how many records we have in each month. So in general, we have almost 2 billion of records for the 2017, divided as follow: almost 100 million of records for January, and over 200 million of records for October, for example. This data set acquired by us from CLS comes with in 12 CSV files with the following available fields, 25 fields that we not specialized before to import data in a database. So when we try to import this data set into the database, it emerged that some messages still contain byte characters, which caused the import process to fail. So it was necessary to remove these byte characters from the CSV using the sed and the hawk command launched from the utilities from the Linux shell. So we import the CSV files in the corresponding tables in the Postgres database. And to speed up analysis and query, it was decided to remove unnecessary fields and keep only those fields used for the calculation of vessel density. So finally, from 25 fields we store in our database just these fields, specialized in the data types, the MMSI, the date, the time, the longitude, latitude, the IMO, and the AIS ship type. We added indexes to speed up query and a primary key too. Another step in this part was to create a vessel register, because it turned out that by querying the data that some MMSI numbers is associated to more than one a ship type during the year. So in these instances, we attributed to an MMSI the most recurring ship type by counting data by ship type AS code. Finally, we get this register, and we import the register in the database again, and we join the register to the single CSV mounted files, mounted tables, to obtain the tables by ship type for each month. It means 13 tables for each month. We decided to create macro categories for ships, because the AIS data comes with a lot of ship types. So we created 13 categories: other, ships, fishing, services, dredging, sailing, pleasure craft, high-speed craft, tank and towing, passenger, cargo, tanker, military, and unknown ships. So the total number of CS5 obtained was given by the 13 EMODnet ship types multiplied by 12 months. It means 156 CSV files. So the following step was to create points. To do this, we develop with Lover Jones, maybe we'll add something more detailed later, a script that process CSV file to get points. Basically, this script was used to project data from WGS84 to Lambert equal area map projection. We choose this projection because the equal area is mandatory to calculate vessel density values that is the same for all the part of our ocean. So we concatenate the data and time fields into a single feed. We add to each record the coordinates and the timestamp of the using calculating the coordinates from WGS84 to Lambert equal area. So I don't want to bother you with all the workflow to create points, but it is something that we will show you in the report. This is the workflow. We start from the input CSV file. We create a temporary file, XY file. We project this data into Lambert equal area. So we do other steps to avoid errors in ArcGIS, and we add the date time field, concatenating the time and the date fields together, and we finally calculate the X and Y coordinates in Lambert equal area map projection. So finally, we obtain a point feature class stored in a file database with the following fields. This is an example of point feature class for the month of December in the channel, in the English channel. The steps after creating point, it was to creating lines. To do this, the script we developed firstly add to each record the sign number, coordinates, and the timestamp of the preceding records. So Alessandro was talking about creating segment each 2 positions and give to these records in the database 4 values of coordinates and the difference in time between the starting and the ending point of the segment. So this is was possible. It was possible to do this using a model and a Python script inside this model. And the final result was to we obtain lines representing shipping routes with the following information: the starting point and the ending point of each segment, the difference in time between the starting and the ending point of the segment of the journey, and the length of each segment. So after these 2 steps, we import the grid polygon feature class and lines in another PostgreSQL database. enabling the PostGIS extension. To import data in PostgreSQL, we use the OGR to OGR GDAL command. And we developed a script run in PostgreSQL that perform the following steps. The script intersects lines with the grid using the PostGIS function st_intersection. We add the fields and calculate the length of each segment using the PostGIS function st_length. We add another field, segment time, and calculate the segment time to be segment length divided shape length times line time. We sum the segment time within each grid square. We join the values to the 1 kilometer grid in a new grid table. The result was a new grid polygon object with a field containing the number of hours spent in all cell by each ship type per each month. Overall, there were 156 files, 3 gigabyte, 0.5 each. All these steps took days to obtain final data, between 16 and 26 hours to obtain point for each month. Another day to obtain to calculate lines, and another day to calculate the vessel density tables in PostgreSQL. So it's a long process because the amount of data is very huge. So finally, after the density calculation, we creating maps using the rasterized GDAL command. It was possible to convert Postgres density tables into TIFF files using the spatial extent of the grid and setting null values as minus 9999. So we obtained the 180 more or less GeoTIFF files with 20 million cells each and a size of 184 megabytes. So I hope it was clear enough, but next week you will find the method, that I'm showing you here in a dedicated publication. We are here also to answer to all your questions about software used, model used, scripting, and so on. So thank you, and I'm going to give to Will the possibility to speak.
Hello there, I'm Will from Lovell Johns. We maintain the website, so I'm just going to talk a little bit about data availability. Hope you can hear me okay. So as well as being able to view the data on the portal, the data is also available for download and also web map services. These are available from the metadata page, so you can go through the legend or you can go to the search data page on the portal, which is under the data services tab.
Will, sorry for interrupting. Would you like to, is it okay if you share your screen so that people can see what you're talking about?
I think so, yeah. I'm using two monitors, which might cause a problem, but yeah, let's see. Okay,
I'll make you a presenter then, because otherwise nobody will see what you're doing. Okay, you're the presenter now. Yes, and we can see your screen. Okay, sorry, go ahead.
So there's a blue icon there in the legend, and that will take you to the download page. Or you can use under the data services tab, you can go to search data, and you can just search for vessel density or vessel, and it should be listed there. So the metadata page contains the standard metadata. Will tell you all about the data sets, how it was made, things like contact details and so on. And at the top of that page, you have several options. View data just takes you back to the portal page. And then you have download data, download metadata, and the WMS link. So going to the download data, we do ask you for organisation name, email address, and industrial sector, and maybe telling us a little bit about why you're using the data set. The reason for that is it's really important to us to be able to show how the data is being used for sort of future funding and keeping this data freely available. And we might email you just to ask you if we can use your project as a test case. So because it's really important to have practical applications of the data. So I'll just fill that out quickly and you can see the list of data. And there's a link to 2017, and there you'll be able to download the data by month. So within each month, you'll have a GeoTIFF for each ship type. And there's also the average one at the bottom there. So the data that you get is a GeoTIFF, and it has the raw value. So it'll have the hours per month within each cell. So that enables you to load it into a desktop GIS and style it and interrogate the data how you wish. In the same way, we can ask for the web map service links. So again, at the top of the metadata page, there's a link there to WMS. You fill out the same details. If you fill it out a second time, it should remember them. And then really this gives you examples of the web map services requests. I won't go through those now, but essentially there's a URL and you can put in a different code for a different ship type, and the month as a number, and you should get the correct web map service. In the near future, we're also looking at introducing a web coverage service. And the idea of that is that, again, you'll be able to use the raw data as a web service. And it will also be available, hopefully, as a time series. And that would enable you to interrogate the data by time. So, for instance, in your GIS software, you'd be able to click on a point and hopefully get maybe a graph up of the different density in that location over a time period. So yeah, that's another thing that we're looking at in the near future. We're also moving the data to a new server. It's a little bit, it's not as fast as we'd like it at the moment, especially when there's a lot of traffic. So that's also something that we're looking at. And it will also have the latest version of GeoServer, enabling us to implement things like the WCS and the Inspire compliant web services. And we'll also add the new vessel density data as it becomes available. So if you have any ideas for any new tools that you might want to see on the portal, let us know via the contact form or the live chat. So that's it for me, and I'll hand back over to one of the other organisers.
Okay, thank you very much. So we receive a lot of questions. If you want to have a look, you have this little question icon at the bottom of your dashboard. And I see that, Alessandro, you already replied to some in writing.
Yeah. Well, there are only two missing. I can reply right now, and then if in the meantime, if someone else has other questions, well, of course, feel free to ask. We're here for this. So, no question from Bas Binnert's been answered. Another question. Okay, plans to enhance coverage in the North Sea. Well, frankly, we received, we're pretty sure to have good coverage of the North Sea, because we have, we're using satellite and terrestrial AIS data. So in theory, we double check this with our provider, with other sources. we don't think we have full coverage of the North Sea. It's possible that we here, here and there we might miss a message, but on average, I don't think we have any particular problems. If you notice something. Something strange, or perhaps a signal or poor coverage of certain areas, please let us know that, and we will double check with the AIS data provider to make sure that we are covering every area of EU waters. Okay, plans to add more derived ship type, I answered that. Plans to include VMS data, not for now. From what I know, because we've been working on this with the experts from the JRC, the Joint Research Centre of the EU Commission, it seems that it's very difficult to get access to VMS data. Both the JRC and ourselves would be glad to work on VMS data if only we could get access to VMS data. So no plans for the moment, but you never know. It would be great if we could be given access to VMS data. So it's not included, of course, right now, only AIS. Plans to include statistics besides mean shipping density? Well, why not? That's exactly one of the reasons why we wanted to have this webinar, also to elicit feedback from users, and to get these sorts of bright ideas to improve our service. So, well, I think we can be in touch after the webinar, and perhaps if you have some specific ideas, well, if it's feasible, I'd love to implement it. Plans to include length, draft, speed as additional sorting criteria. It can be done. Draft is a field in an AIS message. Speed, of course, it's very easy to calculate. Length, well, the only problem is related to quality of data. AIS data suffers from very poor quality. Well, they were conceived for other purposes, not for this type of analysis. They were conceived for, real-time monitoring. And when you get down to analyze AIS data, you find there are a lot of limitations. So we sometimes you have wrong attributes in a field, and it's very difficult to work with AIS data. So initially, we wanted to also take into account draft, for instance. It's possible that in the future we'll be working on it too, but we need to be sure that we have the quality, the information quality is good enough. Then last question is it possible to receive a copy of this presentation? Yes, of course. Well, we record in a video, so as soon as it's available, we'll let you know. And we'll also be publishing a method, the full method to create the maps will be published next week. I guess next week or in a couple of weeks. We're reviewing it. So and it will be a user-friendly method, which means that there's first the theoretical part, so what I said about density and why we came to this solution of measuring density, and also more geeky part with all the steps we used and the various pieces of software we had to use. So ideally, if one has access to AIS data, they can read our method and reproduce exactly the same results for other regions of the world by themselves. That's our idea. I think I answered all the questions. No, sorry, there are some that I left unanswered. Why buy data from commercial businesses when such data are offered through free governmental services? Well, that's a hell of a question. The thing is that only some governments offer free AIS data. It's just, that's an incredible problem. I'm sympathetic to you. It's outrageous that public money is being spent on buying the same set of data all over again, because we're not the only EU contractor that bought AIS data, rest assured. But well, what we can do is to, work to increase awareness about this, because it's really ridiculous that we don't have free AIS data everywhere. We can strip them out of commercial information, confidential information, such as ship owner names, etc., but we do need free access to AIS data, you're right. When you created the area of interest, you removed the land. What about the idea to extend also to the inland waters, the maps? The question from Mattia. Well, in the next update, we'll probably include inland traffic, because we already have the data on inland waterway traffic. It's a matter of extending the grid, but it's definitely doable, and we're probably going to do it with the next update on with 2018 data, which is due later this year. So stay tuned, because in 2019, this density map will receive an update with 2018 data. What will the format of data be beside raster maps? Well, no other format is envisaged so far. If you have any other ideas, please let us know. I cannot guarantee we can make it, but please reach out and let us know. Only rasters for the time being. What about the time series from earlier years and until today? It's something that we've been talking to with our data provider. In theory, we can have data from 2019 to 2016. In practice, it's a matter of, as always, time and budget, because AIS data are very expensive and we bind them for a very large area. Now, historical data tends to be a bit more on the cheap side. Okay, they're not as expensive as real-time or almost real-time data, recent data, but it's still a lot of money. So we need to talk about this, and it also depends on the EU Commission, which is our client, what they want to do. It's definitely something that I would like to do, and we're working on it. Coverage in the Arctic Sea, which is an area of interest with EMODnet. Well, we're covering, I think, the European Arctic. If you see the polygon of the area of interest, we not the entire Arctic, but the whole European Arctic. In future updates, if this becomes relevant, we can also extend our area of interest to cover the whole Arctic. Not a problem whatsoever. Also in terms of budget, I mean, the traffic is not particularly intense over there, so it doesn't affect our budget too much to work with the entire Arctic. Again, if you reach out, we can share with the EU Commission your views, and perhaps we can expand our coverage. Okay, these other questions is left unanswered. You initially cut the cells according to the coastline. There is no effect of the land present in the cells close to the coast having an effect on vessel density in that areas. I don't know if maybe Luigi wants to answer this question.
Yes, about coastline, we cut the area of interest using an inner buffer of 1 kilometer from the EA coastline, avoiding in this way to miss some positions because of the quality and accuracy of the coastline. So the grid goes from far to 1 kilometer from the coastline.
Okay, thanks. We're running a bit late. I'll try to be as quick as possible here. Okay, other questions left unanswered. We've done something similar to calculate UK shipping emissions. It's talking of which, it's one of the future evolution. We would like to also estimate or calculate shipping emissions. Of course, we're going to need much more data on ship engines, on fuel burns, etc. But it's one of the possible evolution, and I'll be in touch, because it would be good to see what you've done and maybe build on your method too. So thanks for letting us know. It's possible. Show 6 months at a time. Well, yes, it's possible. We can introduce it. Not right now, maybe because we're still, finishing everything. But it's possible. If users are interested, it's definitely possible, and it doesn't take long. I was easily able to download monthly density, but average density gives me an error. You're not the first user to report this. I guess it very much depends on the software you use to open the 7-zip archive. But if you left your email, it'll be my responsibility to send you the files uncompressed. In the meantime, we'll work out on this problem because several users are reporting the same error with the average density. I have had issues downloading your WMS into ArcGIS. Can you confirm the link is working properly? I've been in touch about this already. Okay, Will, do you want to take this question? Will? Okay. Are you at your microphone muted?
Okay, can you hear me now?
Yes.
Yeah, as I said, we have had experienced some problems when we've had high traffic, so we are looking at that. But the WMS should load into ArcGIS and QGIS, okay? We were aware of a problem yesterday that they weren't working in ArcGIS online, so again, that's something that we need to look at. But if you send a query through via the help, we can have a look at that.
Okay, thanks. And please let us know if you continue having issues with WMS. Okay, didn't understand the format of the data we downloaded. Well, it's a raster file. If there's something, maybe Luigi wants to add something about that.
I had the answer. Yes.
Okay, all right.
So the format is a GeoTIFF floating raster with density values stored in it. So you can download the GeoTIFF and perform all the spatial analysis you want, because you have in the GeoTIFF the floating values of in hours of the vessel density.
Okay, so this was the last question that was left unanswered. If there are no other questions, I would end the webinar here because we're already running late. We promised finishing at 10:45. Well, it's almost half an hour, but okay, sorry. It means that there were a lot of questions and the topic is very interesting, so it was worth it. Andrean?
Yes, so we will finish here. Thank you very much for your participation. We hope that you find it useful and interesting, this webinar. And as we said, if you have more questions, more clarification, or you want to give us feedback on the EMODnet human activity portals, you will find all the contacts, so to the help desk or the contact us icon. So please send us your questions. And so that's it. Thank you very much, and we wish you a nice day.
Thank you, everybody. Bye-bye.
Thank you. Bye.